Assalamualaikum and very good morning. My name is Muhammad Anis Mustaqim bin Muhammad Shuaimi, and my metric number is CE210188. Okay, today I will explain about open loop position control in exercise 3.3.1. Okay, in activity 1, okay, the first thing is key in all parameter value into the simulink block. Okay, I have key in the value. And then the second question is check the block simulation by key in the input angle value is 1 and trigger value is 1. Okay, here you can see I input it and there's the value at the input voltage and the shaft motor position. So that's mean it's functioning. This block is functioning. Okay, now for the question 3, increase step-by-step value of input angle from 0 till 10 and set attenuation gain 0. Observe the shaft motor position display and what happened to the system. Below show result of the MATLAB simulink. Okay, here is figure 3.1. Show that input angle is 0. Okay, here. And the shaft motor position is 0 and this also 0. But when the shaft input angle is 10, the input voltage is 6.1111, while the shaft motor is still 0 because penetration is 0. Okay, so here are the result from table result from 0 to 10. So you can see the input voltage is increased, but the shaft motor position still at 0. And this show that if the attenuator gains equal to 0, shaft motor position will not change whether there is voltage or not. Okay. And for the question 4, same as the question 3, but attenuator gain from 0 to 10 and set input angle to 0. Okay, here are the table result, which is with no input angle, there is no input voltage, so there is no changing in the motor position. Based on table 4.1, it shows that if input angle equals to 0, there is no change in shaft motor position, whether the attenuator gain has value or not. Okay, here are the question 5. Okay, I will simulate. Okay, so here are the circuit that we need to build. Okay, as you can see, you get 58.64, which is the same 58.6. And if you want to go to the anti-clockwise, just put here the negative. And then the circuit will be in the anti-clockwise position. Okay, so the next is 10. So we put here 10. And run it. See, the input voltage is increased. The shaft motor also, my bad, sorry. 5. As you can see, input voltage is increased. The shaft motor position also increased. As the table show. Okay. For 360 angle, input voltage is 220 and the shaft motor position is 33,779.19. Yes. So it shows that when input angle is getting higher, the input voltage will also increase and the shaft motor position will also increase. Okay, here are the error percentage for the input angle 5. So the potential gain, potentiometer gain, divide by the shaft motor position and times with 100% and you get 1% error percentage. And here you get 0.1%. And for the 360, you get 0.002%. Okay, that's all for activity 1. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ismahani binti Muhammad Jaswadi and my matrix number is AE190028. Okay, for the next, I will continue to present for the activity 2. Okay, so this is for the closed loop circuit control system. So here we have input angle, position sensor input, alternator gain, electrical part, mechanical part, and integrator. And this shaft motors position display, this scope, and position sensor output or potentiometer output gain. This is output voltage. So now, first we need to set the electrical part with 1/2 0.121 S plus 11.2, and for the mechanical part we set as at 1/0.222 S plus 0.003. Okay, next I will going to run for our circuit when the input angle is 5, positive 5, and the alternator gain is 1. Okay, the result we get for the input voltage is 3.056 volt and the shaft motor negative 0.215, and for the output voltage is negative 0.3798. Okay, next we're going to change the input angle with negative 5 when the alternator gain is 1. So now we're going to run it. So this is the result for the input angle negative 5 and alternator gain is 1. For the input voltage we get negative 3.056 volt. For the shaft motor position negative 8.475, and for the output voltage is negative 5.179 volt. Okay, next we're going to change the input angle with the 150, positive 150, and the alternator gain is 5. Okay, now run it. Okay, this is the result when the input angle is 150 and alternator gain 5. So for the input voltage we get 91.67, and for the shaft motor position we get 136.3. For the output voltage we get 33.26 volt. Okay, next we're going to change the input angle at negative 150, at alternator gain 5. Okay, now we're going to run it. So this is the result when input angle negative 150 at alternator gain 5. So the input voltage we get negative 9.1 9.167 volt, and shaft motor is negative 140.3, and for the output voltage is negative 85.74 volt. Okay, now for the next, we're going to change the input angle value again with 360, and at alternator gain at 8. Okay, this is for the positive input angle. Okay, this is the result when the positive input angle 360 at alternator gain 8, and the input voltage we get 220 volt, and the shaft motor position is 313.7, and the output voltage 191.7 volt. Okay, now we're going to change the input angle at negative 360. Okay. Okay, here as you can see, when the input angle at negative 360, alternating gain 8, so the input voltage we get is negative 220 volt, and the shaft motor position is negative 310.1, and the output voltage is negative 189.5. So that's all from me. Thank you.